Hello. We are going to learn a little secondhand way to do what we did yesterday with our decision charts. First, we're going to start off with this first problem here. And let's just take a look at it. And we have, this is ideally what happens with your schedule every year. We have a student, Marcos, taking some classes next year. We've got English, physics, government, pre-calc, Spanish, and journalism. So that's 6, and he has 6 periods in the day. How many different ways could we have his schedule for school? So ideally, if you have 6 periods, you've got first period, second period, third, fourth, fifth, and sixth. So when it comes to first period and you look at your 6 classes that you could take, you could have any of those 6 classes first period. Then second period, you've already taken one of the classes first period, so now you only have 5 options. And eventually, as we move through the day, we're going to lose one of the options every time, so that by the time you get to 6th period, you only have the class that you have left over. So you're going to take all those, and you're going to multiply them, and you're going to have 6 times 5 times 4 times 3 times 2, and you're going to get 720. What we're going to learn today is a second way, real quicker, easier way to do 6 times 5 times 4 times 3 times 2 times 1, and it is something called a factorial. Some of you guys might have heard of the word factorial before, but it is a shorthand way of saying you have a multiplication of numbers that are decreasing. And actually, I'm going to highlight for you guys, this is the actual formula for n factorial. And it goes down until you end up with going 3, 2, 1. So n factorial is any whole number that you start with. It has to be positive. It's a whole number. And what it means is you're going to take that number and you're going to take every number you're going to take away 1 every time. And you're going to just multiply this string of numbers together. And you just keep going down until you get down to 1. So if I have a small number like 4, it's really just 4 times 3 times 2 times 1. But if this was a big number like 20, it would be 20 times 19 times 18 times 17 times 16 times 14. And you're going to go dot, 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 dot all the way down until eventually you get down to 3 times 2 times 1. So when we're doing some of these problems, instead of having to write out just a big long decision chart, you can just recognize if it's decreasing every time. Hey, I can just represent that as a factorial. So if I went back, and notice this is 6, 5, 4, 3, 2, 1. Oh, I could have just said, okay, it's going to be 6 factorial. I do that in my calculator, and I'm going to get 720. I'll show you how to do it in your calculator then in a second. So we're going to do a couple, but you need to know your calculator first. So I'll pull up my calculator. If you hit the math button, and you arrow over to where it says PRB, that means probability, because a lot of actually this unit, it ties together with the stuff that we did in probability. But if you'll notice here, you can see on 4, there's just an exclamation point. That means factorial. So what we would want to do is if I wanted to do 6 factorial, like we did in that warm-up, you would do 6, you'd hit the math button, whoops, math. You would go over to probability, and you would go down to the exclamation point. So in your calculator, it looks like 6 exclamation point. That really means 6 factorial, and your calculator do it for you. So how many distinguishable batting orders do we have from 9 players in this baseball team? So ideally, you have who's batting first, who's batting second, who's batting third. And as you move through the batting order, you can't double bat. So hopefully you recognize that that's going to be 9 times 8 times 7 times 6 times 4 until you get down to the last person who's just the automatic batter then. So this actually is 9 factorial. You don't have to write the decision chart if you can recognize it. You can write the decision chart if you wanted to. It's just another way to do it today, essentially. So I go to my calculator. I'm going to go 9 math. I'm going to go over to probability. I'm going to go down to the exclamation point. And we have a lot. 362,880. 362,880. So there are a lot. 362,000 different ways that a baseball coach could come up with their batting order. So then you have how many different ways can you arrange the letters in the word fraction? So that's 1, 2, 3, 4, 5, 6, 7, 8. Once you use one of the letters, you can't use it again. So it's going to be 8 times 7 times 6, and then you get down to eventually 3, 2, 1. So we have 8 factorial. So you're going to go 8, math, probability, exclamation point. You're going to get 40,320. All right. And 5 students are running for class president, junior class president. They're going to give speeches. So ideally, you have an order of speeches, who's going to go first, then who's going to deliver their speech second, and you can see that that would be a decision chart. I can write it really quick. If you want to, go for it. No big deal. But that would be also represented as 5 factorial. And after a while, you'll get used to just kind of what they are because they're standard. You'll get used to what 5 factorial is, what 4 factorial is, etc. So 5 factorial is 120. So there are 120 different orders that they could get their speech. Now, I want you to look at something in your calculator. There is, I think it's 18 or 19. I don't remember exactly. Yeah, there we go. Do you notice how this says E? You start getting, so your calculator is handy. It does this stuff for you. However, it gets to a point in time where the number gets so big because you just keep multiplying by other numbers that it actually has to take it into scientific notation. If you don't know this about your calculators, if you see E, that means times 10 to the, so this would be 10 to the 15th. That ends up being a number. It's too big, it's too overloaded for the calculator to do. So the calculator just gives you this. It's not actually an exact number. So while the calculator can do it, it can only do it up to a point. I don't remember what that point is. I think it's, you know what? No, it's down here in like 14. Let me see. Yep, it does. It's lower than I thought it was. So you can see there's a switch. So it can basically handle any factorial under 13. And then it just gets so large. So there are going to be problems that we get to later on where you just simplify factorials. Now, this first one, the calculator ideally could do, you could do 10 in your calculator, 10 factorial, you could do 8 factorial, or you could think of it this way, and there's a quick and easy way to simplify this by hand, which actually works out really nice. It's really fast. If you think about what 10 factorial is, 10 factorial means 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. 8 factorial means 8, 7, 6, 5, 4, 3, 2, 1. And if you look at this and know what you know about simplifying fractions and such, if you match up with a number in the top, you can cross them off. So it turns out that this answer is just going to be 10 times 9, which is really easy to do in our heads. That's 90. So yes, this one could have done this by itself, but then we get over to a problem like this, which you will see in a formula later on. 2018, our calculator would not be able to handle. So if you think about simplifying this by hand, you would have 20 factorial would be 20 times 19. And we can actually shorten this out and not write all those numbers down. If you think about it, it would then be 18, 17, 16, 15, 14, and 18 on down can be represented as 18 factorial. I already have an 18 factorial down there, and a 2 factorial means 2 times 1. So ideally, I can do this actually really quick and represent 18, and all numbers from 18 down to 1 are going to cross off with each other. The other thing that's going to happen is that 20 and 2 will simplify down to 10 and 1. So if you start to recognize that these things can happen, you're going to end up having just a simple, much easier in your brain without a calculator to do. You're going to end up in this case with just 10 times 19, which is 190. Okay, so you're going to see some of these then as well. And we can do this with the definition of what a factorial is as well, where we don't have numbers, but we have variables. And this one's a little bit harder, so it takes a little bit more thinking. But if you think about what you have here, you have n plus 2 and you have n. And if you think about which one's bigger, n plus 2 is bigger than n. So if I started with that one and I had n plus 2 times n plus 1, because it's 1 less, so you take it away, 1 less than n is n. 1 less than n is n minus 1, and that's going to just keep on going down. You're going to end up having on the denominator n times 1 less than n is n minus 1. 1 less than that is n minus 2. 1 less than that is n minus 3. And that's going to go all the way down. And you're going to see some things start to match up here. You have n and n, they'll cross off. You have n minus 1 and n minus 1. You have n minus 2 and n minus 2. And actually, all this stuff will cross down. So it turns out that you just have n plus 2 times n plus 1. And I don't need you to multiply that together. You can just leave the answer like that. It gets a little tricky when you start at n minus 1 because there's a difference between negative 1 and a positive 1. So in your denominator, you got positive 1. Take a positive 1, you're going to get to 0 or just n. Then you start to subtract. So n minus 1, take 1 away, you get to negative 2, you get to negative 3, and it goes all the way down. If you're starting at n minus 1, this is actually a negative 1. So if you think about a number line, 1 less than negative 1 is negative 2. 1 less than negative 2 is negative 3. And that's going to go all the way down. So it turns out that you have n minus 1, n minus 1, n minus 2, n minus 2, n minus 3, n minus 3. And all of that rest of that stuff will cross off. So you are left with an n plus 1 and an n, but be careful, they are left over in the denominator, so they need to stay in the denominator. And so therefore, you have 1 in the numerator. There's a worksheet 2, that I would like you guys to complete. I will check it when I see you again.